Hey everybody! So based off the sample problem I just showed you, you have 10 grams of aluminum that's going to react with 35 grams of chlorine gas to produce aluminum chloride. Now what you're trying to solve for is figure out how much product you're going to create, what is your limiting reactant going to be, and what is your excess reactant going to be. So let's pull out all that really important information, okay? So we know for aluminum we have 10.0 grams available to us. For chlorine gas, we have 35.0 grams available to us, okay? Remember, we're trying to solve for grams of aluminum chloride. Now, you may notice, okay, there's a huge difference between 10 and 35 grams. Do not let that fool you. Don't automatically assume you know that you're going to run out of aluminum first because it's a smaller mass. Just because it's a smaller mass doesn't mean anything. It all has to do with your molar mass as well. In order to truly figure out what your limiting reactant is going to be, you need to do some mass-to-mass conversions. So lucky for us, we only have one product. Now remember what I said earlier, if you have multiple products, when you're doing mass-to-mass conversions, you need to make sure you choose only one product to do these conversions to. Because if you're doing mass-to-mass conversions and you're going to all these different products, you're not going to be able to solve the answer. You need to do these conversions going to the same product each time. So what we're going to do first is we're going to do a mass-to-mass conversion going from one reactant to the product, and then do the same thing again using the other reactant to the product, okay? So in this case here, I'm just going to start with aluminum first because it was first on my list and it appeared first in the question. So, my starting point for aluminum is going to be the 10.0 grams. I'm going to set up my T-chart. Now the very first thing I need to do is I need to convert grams of aluminum to moles of aluminum. Now in order to do that, I need to look at my molar mass for aluminum. Now for aluminum, you're going to have an atomic mass of 26.98 grams, okay, per mole. Now if you notice, it hasn't understood one subscript, so I don't have to do anything to that number. So all I'm going to do is I'm going to automatically plug it in here. So I'm going to put the 26.98 grams on bottom and the 1 mole up on top. So my grams of aluminum cancel out. The next thing I need to do is convert from moles of aluminum to moles of aluminum chloride. Remember, the only time that you can go from one compound to another compound is when you're in moles. So I want to look at my coefficients. I need moles of aluminum on bottom because I need that to cancel out. I look up here, found aluminum. It has a 2 coefficient, so I'm going to put that 2 right here and say 2 moles of aluminum. Okay? I need moles of aluminum chloride up on top. I look for aluminum chloride. It has a 2 subscript, so I'm going to put 2 coefficient, sorry. So I'm going to put 2 moles of aluminum chloride up on top. So moles of aluminum cancel out. But we're not done yet. Remember, we're trying to solve for grams of aluminum chloride, and we're currently in moles. So we need to do one more step. What we need to do is find the molar mass of aluminum chloride and then plug that in here accordingly. When you find your molar mass of aluminum chloride, what you should end up getting is 133.33 grams per mole. Okay? So let's take this number and plug it in here. I need the moles to cancel out, so that 1 mole from my molar mass needs to go on bottom. And that 133.33 grams needs to go on top. So my moles of aluminum chloride cancel out. Now I do want to stop right here for just a brief second. So remember what I've said before, when you're trying to figure out your molar mass of something, when you're pulling your atomic masses off of your periodic table, you need only 4 significant digits, right? Once you add everything together, so aluminum chloride, once you add everything together, you know you have more than 4 significant digits. Do not round it to have only 4 significant digits. Leave it as is. If you start rounding these numbers in the middle of doing your calculations, you're going to change your results, okay? So once you start doing this, let it be. do your rounding at the very, very end, okay? So do not round any of these numbers once you figure out what your molar mass is going to be. That's very important. Okay, so now we've gone to grams of aluminum chloride. We've reached our destination, so now we have to go through and do all the math. When you do all the math, you're going to get 49.418 grams. But we're not done yet. Remember, significant digits, so we go to our starting point. We have 1, 2, 3. 3 significant digits. Remember that these 2 zeros that are in here are significant because they come after the 1 and there's a decimal present. Okay? That decimal is what makes those 2 significant. So we have 1, 2, 3. Round this 4 based off the 1 behind it. So it's going to end up staying a 4. So I'm going to get 49.4 grams of aluminum chloride. So basically what this is saying is, let's say we had 10 grams of aluminum and we had an unlimited supply of chlorine gas. I can make 49.4 grams of aluminum chloride. Okay? But that's not what it asks us to do. It wants us to figure out what our limiting and our excess reactants are going to be. So we need to do another mass-to-mass conversion, but this time we're going to work with chlorine gas. So our starting point for chlorine gas was the 35.0 grams. Set up our T-chart. Now our molar mass for chlorine gas is going to be 70.90 grams per mole. Okay? We're going to plug this in here accordingly. Now we need the grams to cancel out, so that means that 70.90 grams is going to be on bottom, and you're going to have 1 mole up on top. The grams of chlorine gas cancel out, leaving me with moles of chlorine gas. Now that we're in moles, we're allowed to convert from one compound to the other compound. And remember, we're trying to get to aluminum chloride. So let's look at our balanced equation. I have a 3 in front of chlorine gas. So that means I need 3 moles of chlorine gas to go on bottom, because I need moles of chlorine gas to cancel out. So I'm going to take the 2 moles of aluminum chloride and put that up on top. Okay, so we're almost there. Now moles. Now all we have to do is convert moles to grams. Here's the really cool part about it. At least for when you're doing limiting reactant problems, the second half of this part is the same as the first. So all I have to do is go, okay, I already calculated out my molar mass for aluminum chloride. I don't have to calculate it out again. So that means less work in regards to that. So keep that in mind, okay? So I'm just going to plug this in as it was right here. 133.3 grams of aluminum chloride over 1 mole of aluminum chloride. So the moles cancel out. I'm left with grams, so I can go through and do my math. When I do that, what you should end up getting is 43.879 grams. But I'm not done yet. Remember, significant digits. Go to your starting point. 1, 2, 3 significant digits. Come to your answer. 1, 2, 3. Round that 8 based off the number behind it, which is 7, which is going to round that 8 up. So you should end up getting 43.9 grams of aluminum chloride. Okay. Now we can actually answer our questions. We want to know what the mass of our product is going to be. We want to know what our excess reactant is going to be and what our limiting reactant is going to be. Now, in order to answer this, what you're going to do is you're going to look at your 2 mass products right here. Okay? One of them you were able to produce 49.4 grams of aluminum chloride. The other one was 43.9 grams of aluminum chloride. You're going to look at those 2 and find the smaller of the 2. In our case, the 43.9 grams of aluminum chloride is smaller. So that means that that is going to be the mass of our product. Okay? Which means if I go all the way back to the beginning, that chlorine gas actually ends up being my limiting reactant. So I'll write that here. We have a limiting reactant, which is going to be chlorine gas. And my excess reactant is going to be aluminum. and the mass of my product is going to be 43.9 grams of aluminum chloride. It's really important that you remember how to do this, okay? And then when you're listing off your limiting and your excess reactants, you are to give me the name of the compounds, okay? A common mistake some people give me is they try to give me a numerical value. They try to find the mass of it. I don't want the mass. All I want is the name of your compound. You can name it out. You can write it out if you want. You can write out aluminum. You can write out chlorine gas. Or you can write it out how it is in your balanced equation, okay? That's very important. And this is a perfect example of why I told you not to assume that since you had less of aluminum, it was going to run out first. Because in this case here, you ran out of chlorine first. So chlorine was your limiting reactant. Aluminum was your excess reactant. Once you ran out of chlorine gas, you could not produce any more. So the maximum amount of the product that you can create was 43.9 grams of aluminum chloride. I'm going to give you another sample problem to work out. Pause it, practice it, restart the video when you're ready, and we'll see how you do.